That app on your phone, the software in your car, even the stuff running our power grid, chances are they're all built on a mountain of open source code. And that's great, until it's not. What happens when a single, tiny piece of that code is actually a ticking time bomb? Well, today we're going to crack open a real-life attack that shows just how scary that can be.
You know, open source software is kind of like a giant community potluck. Everybody brings a dish, shares their best recipes, and we all get to create these incredible meals together. But here's the catch. That openness, the very thing that makes it so powerful, can also be its biggest weakness. We're about to look at a case where someone, a bad actor, slipped a little bit of poison into the flour, affecting every single cake, every single loaf of bread baked from that batch. So, here's the plan. First, we're going to go full CSI and dissect a real-world hack. Then, we'll pull back to see the bigger picture. And that includes a brand new, kind of wild threat that's being cooked up by AI. Let's get into it. All right, so first up, a crack in the code. You might be wondering, what exactly is a software supply chain attack? Well, the best way to think about it is poisoning the well. Instead of going after one person, you poison the source that everybody drinks from. In the software world, that means attackers go after trusted places like the Python package index, PyPI. They sneak their malware in there, and then they just sit back and let the trusted system do the dirty work of distributing it for them. It's sneaky, and it's incredibly effective.
And that brings us to our main character, if you will, a deceptive spell checker. I mean, think about it. What could be more harmless, more mundane than a spell checker, right? It's a tool developers use all the time. But in this case, hiding inside two seemingly innocent packages on PyPI was a really sophisticated piece of malware, just coiled up like a snake, waiting for the right moment.
And the way they hid it, it was just genius in its simplicity. Take a look at these names, spellcheckerpy and spellcheckpy. They look almost identical to really popular, totally legitimate packages. And that's the whole trick. All it takes is for one busy developer to make a tiny typo when they're installing something, and boom, that's it. The gates are wide open and the Trojan horse is inside.
And let me be clear, this wasn't just some theoretical threat. No. Before anybody caught on and took them down, these malicious packages were downloaded more than 1,000 times. That's over 1,000 potential infections, 1,000 compromised systems, all because of one tiny typo. It's kind of terrifying when you think about it.
Okay, so how on earth did they actually do it? I mean, how do you hide a powerful piece of malware inside something as boring as a spell checker? Well, this is where it gets really clever. Let's break down the anatomy of this attack.
This whole thing was just a masterclass in hiding in plain sight. So a developer just imports the package, right? Seems totally normal. But the real payload, the bad stuff, wasn't in some obvious script file that a security scanner would find. Nope. It was buried deep inside a dictionary file for the Basque language. I mean, who would ever look there? And for the first few versions of the package, it did absolutely nothing. It was a sleeper agent, just sitting there, dormant. But then, with version 1.2.0, the attackers pulled the trigger. They flipped a switch, activating the code. It suddenly decoded itself, reached out to a secret server, and downloaded a full-blown Remote Access Trojan, giving the attackers complete control. Just incredible. So where did this Trojan come from? Well, the investigation traced it back to a domain called updatenet.work. And get this, it was hosted by a company called CloudZ. Now, researchers say this hosting provider has a pretty shady history. They're known for providing services to some very sophisticated, very serious nation-state hacking groups. So yeah, this was definitely not the work of some kids in a basement.
And this is the part where the story gets even bigger. This whole spell checker thing, it wasn't a one-off attack. It was just the tip of the iceberg. It was actually one piece of a much larger, carefully calculated campaign that really shines a light on a huge, growing weakness in the entire open source ecosystem.
I mean, just look at the timeline. The attackers registered their domain way back in October. Then in November, another similar malicious package pops up. And then finally, in January, they spring the trap by updating the spellcheckpy package. This shows you how patient they were. This was a slow, methodical, and well-planned operation.
And please, don't think this is just a problem for Python developers. The exact same kinds of attacks are happening over in the JavaScript world, on its big package repository, NPM. We're seeing these malicious packages targeting industrial and energy companies with fake login screens, or going after crypto wallets with info-stealing malware. The battlefield is definitely getting bigger.
So just when you think we're starting to get our heads around these kinds of attacks, a whole new player walks onto the field. AI. Yep, artificial intelligence. And it is creating a completely new and honestly pretty weird set of vulnerabilities. It has this great name, Slopsquatting, and the concept is just wild. Here's how it works. An AI model, like a ChatGPT or a Copilot, is helping a developer write some code. And in the process, it just makes something up. It hallucinates a name for a software package that sounds totally plausible, but doesn't actually exist. Well, the attackers are watching for this. As soon as an AI spits out one of these phantom package names, they swoop in, register that exact name, and upload their own malicious version. It's an attack vector that literally didn't exist a couple of years ago.
And as one researcher, Charlie Erickson, puts it so well, skills are the new code. These AI agents, they just follow instructions. They don't stop and ask, hey, does this package actually exist? Is it safe? Nope. They just do what they're told, blindly trusting whatever they're fed.
And if you're thinking, okay, but how often can that really happen? Well, get this. Researchers found one single hallucinated package name, React Code Shift, referenced in 237 different projects on GitHub. 237. That's a vulnerability literally created out of thin air, spreading like a rumor, just waiting for a bad guy to come along and turn it into a real threat.
So all of this, the typo squatting, the patient attackers, and now this crazy AI hallucination stuff, it really brings us to a massive, critical question about the future of how we build software. As AI starts writing more and more of our code, becoming our co-pilot, who's on the hook when it messes up? Who's ultimately responsible for its safety? Is it the company that built the AI? Is it the developer who used the AI suggestion? Or the platform like GitHub that's hosting the code? The tools are getting smarter, for sure, but the threats are getting smarter right along with them. Which leaves us with this really tough question. In this new world, who verifies the verifier?